ductility, some deformation, some indication of any failure, something like this. But for high strength steel, you can count your failure suddenly.
So the member is due to fail before the weld is due to fail?
No, no, no. Because your member failure at this value. But failure for welded material, here is your FEXX 0.6 FEXX may be higher than this value.
Right, so the weld is stronger than the member.
Yeah, yeah, sometimes.
Tensile strength.
Yeah, yeah, yeah. So at any situation, you have many design for B ultimate. Your B ultimate must be smaller than or equal Phi Rn, and your Rn equal 0.9 F ultimate area gross or 0.75 F yield area effective, if you remember under tension, or F critical area gross, if you remember under compression. So you are in the stage to avoid any failure in the member itself. Right now, we have another situation. Your B ultimate in your member must be smaller than or equal design strength of your connection. If you satisfy this condition and this condition, you cannot expect any failure for your member or your connection. Okay? Also, how many or how much this one is smaller than this one? How much this one is smaller than this one? Maybe, for example, if your B ultimate equals 60 and your design strength of your connection equal 58 and your design of your member equal 40. So what do you think? What will be the failure in the future? Because you are very close to design strength of your connection. But here you are very far away from the design of your member. So this one will be more critical. Okay? You said the material is stronger than, but not only the material is the only one factor. We have another factors, size of weld. Maybe you have very strong material to make weld, but you have very small size. Maybe you have very small length of weld. So not only the material will control the design. Anyway, so first for welding connection, I need to figure out what is the type of electrode rod I will use. Which one is available to buy it. Then I can figure out what is the value of FNW by multiply 0.6 times which value. Then go ahead and use this value by multiplying it by what is the size, what is the length of weld by 0.707. You can get your nominal strength. Multiplied by Phi, I can tell you what is the design strength, then make your comparison between the factor load and design strength. All of these factors, all of these process only if your member with the force B ultimate in the same direction of your weld, which called longitudinal weld. For this one, actually, for this one, we have a force, tensile force in your member. So your weld will be something like this, something like this. So your weld in the same direction of your load, so we can call it longitudinal welding. If you add another weld in this direction, like this, in this direction, which is perpendicular to direction of your load, this weld called transverse. Actually, you can do it, you can do this. Longitudinal and transverse. Both of them at the same time, that's right. no problem. But if you are talking about Rn equals this number and multiplied by 0.75, you can get your design only if your weld is a longitudinal direction. But if you have longitudinal and transverse weld at the same time, like this one, your gusset plate, your member, and you did welding in this direction and this direction, which called longitudinal. Why longitudinal? They are parallel to your load. And transverse direction, which is perpendicular to the load. So right now we have longitudinal and transverse. Then go ahead and use this equation or this equation. The larger one, I will use the larger value between this equation and this equation. I'm sorry, what you mean by Rn equals this value plus this value or this value plus this value? This one is the same value, 0.707 WL FNW. This one will be 707 WL FNW. But the first term or the first value for longitudinal. What you mean? I mean W and the L for longitudinal. What is the W for this weld? What is the length for this weld? Longitudinal. The second term for transverse. What is the W for this weld? What is the length for this weld? Or 0.85 for longitudinal plus 1.5 for transverse. Get a value for Rn in the first case, get another value for Rn in the second case, and use a larger value. This will happen only if you have in your connection both of them longitudinal and transverse weld.
So on the longitudinal one, do we use 6 inches for the L?
Yes. Which 6 inch?
Yeah, the longitudinal ones, you have 2 welds that are 3 inches each?
Yeah, you have 3 inch here and another 3 inch here. So your L will be 6 inch. And for transverse, what this length will be 3 inch only. So maybe your size will be the same. Size of weld here, the same like here, the same like here, maybe 0.5 or quarter inch. So go ahead and put your W. I think the material will be the same. The material used in this weld will be the same like this one. So this value will be the same like this one. Go ahead and get this value, and put your numbers, and get Rn and another Rn, and use the greater one.
What's NW, net weld?
I'm sorry?
RNW, net
N
weld?
means nominal.
Nominal. Weld.
Yeah. Okay, let's do an example. Welding connection is very easy. We have plate used as a tension member. So this one is a plate with thickness equal quarter inch. To a gusset plate, we have another gusset plate with thickness T equal 3/8 inch. The welds are 3/16 inch. Welding size equal 3/16 inch. Put it in your mind. We have a gusset plate maybe I can draw 3D, something like this. Here is your gusset plate, and here is the connected member. Okay? Between this member and this member, at this location we have right angle. Between this edge and this surface we have right angle. So 3/16. 3/16 I will do weld. You can imagine? One more time. At this location, 3/16 inch. Your height, 3/16 inch. Then you will make a triangle, and this triangle will extend in between. So your size or your weld will be something like this: 3/16 inch, 3/16 inch. This one, this side is parallel to the vertical face of the thickness of your plate. This one will parallel to the surface of the gusset plate. And this shape will extend with a length equal 4 inch only. Only 4 inch. From this side and from the other side also. So your W from this information equals 3/16 inch, which called weld size. Second information, the weld, the fillet weld made with E70XX electrodes. I went to the store and I found the available electrodes with this type. So FNW, which equal 0.6 F what? XX? EXX. 0.6 FEXX for your electrode equals 70, based on the manufacturer. 70. Depend on what is the type of electrodes, the rod used in welding. Then I can tell you what is the value of FNW. Also, from your connection, your length of weld equal 4 inch. Actually, we have another 4. So your L equal 8 inch. What is the total length of your weld? Actually, we have 4 inch from this side and another 4 inch from the other side. So your total length of weld equal 8 inch. Then go ahead. What is the value of nominal strength of this welded connection? Rn equal 0.707 WL FNW. That's all. 0.707. Size of weld equal 3/16. Total length of weld equal 8 inch. FNW equal 42 KSI. So I can tell you what is the nominal strength of this welded connection. 44.5. Kip. If you would like to get your design, so Phi Rn, you can multiply this value by 0.75. Your final value will be 33.4 kip. So, if you have P ultimate acting in your member, your P ultimate from structural analysis must be smaller than or equal 33.4 to satisfy your weld connection.
Yeah.
Hey, what will happen if your P ultimate from structural analysis in your member is greater than your design? What should I do? We have three options, but we will start with the most easy one. I think the most easy one, increase your length. Your length of your weld. 4 inch, maybe 5 inch, 6 inch. The second option, increase your size of weld. Rather than 3/16, go ahead and make it 4/16, which is 1/4, or 5/16. The third option, change the type of your used electrode. You used E70XX, maybe 80, maybe 90, maybe 120. But this is the last option. But I think the first option you can change. First one, change the length. If the length not enough, okay, go ahead and change the system. You can add, what's this? Transverse welding. Then we will go to another calculations, which will be the second example.
Dr. Ayman,
Yeah,
the welds don't have to start at the corners? Like you
no,
can-
no, as you like. Maybe start from here to here, from here to.
As long as you have.
I don't care where is the position of your weld, but my concern, what is the length? Okay?
Most people do start at
You can't go higher than a quarter though, right? On the weld first,
No.
for like.
No, no, you cannot.
In the middle.
You cannot go higher than 1/4 because your
The thickness,
thickness of this blade,
You can
something
go-
like this, and the other blade, something like this.
Yeah.